Hello, welcome in 3CL4 lab. Today I will give you a short video about what will you do in lab 2. Okay, if you open the lab PDF on the website, lab 2 is about closed loop system identification. We want to identify the plant model of a marginally stable servo motor. The lab assessment is about two parts. The first part is 7 questions that must be completed before the lab. This is section 1 and 2. These questions are something based on what you have done already in lectures. If you understand your lectures, you can make the derivations required and finish these parts at home before you come. In the lab, you will finish 2 experiments, which I'll show them to you now, which are section 3. Then you will do one writing exercise. It's one writing exercise. Also in the lab, it is section 4. So the 7 questions must be done at home and get prepared to these experiments here, and then you will write your exercise in section 4. So all the marks will be done during the lab. So get prepared and let's start this. So this is the description. This is something based on what you have already done in lectures, questions with the marks between them. This is easy to follow. If you really understand the lecture, this is easy. Okay, you finish this part at home, so you'll start part 3 in the lab. We will need to connect 2 circuits, the summing amplifier and the unit gain inverting amplifier. If you remember the amplifier circuits, this is R1, this is R1, so the V input and V output are just the inverse of each other. V output is the negative of V input. Here the V output is R1 VI1 plus R1 VI2 over R2. We will choose here R2 to be equal to R1, so the volt here is just the sum of these 2 volts with appropriate signs. So this is the output, negative R2 over R1, V1 plus V2. R2 will make R2 and R1 equal, so it is negative this volt plus this volt. And okay, so this is the circuit that we will use. The volt input here is the supply volt. We get negative here. The volt here is actually the angle output from the servo motor, which we have already used in lab 1. So we want the augmented circuits. This is the inverter and ground. This is the volt V1. This is the volt V2. This is the command input to the servo motor. This is the command input that we used the 12 volt and negative 12 volt last time. This is the angle output, which we used last time, and this is the control unit that we are using. Okay, so we want to make this model and go through the experiment. What we'll do now, first point is easy, just connect all the grounds with each other. We'll adjust the signal generator to produce a 6 volt peak to peak square wave with frequency 0.1 Hertz. We'll adjust the scope, the vertical and horizontal axis, and put the scope in rolling mode, and make sure we have this square wave on the oscilloscope. After making the circuits, we'll need to set the motor to inhibit, set the resolution to 2 revolution, and make sure that the overshoot we have in this case is about 40%. Let's go and do this part and just talk about it. So okay, the first part, we need to adjust the function generator to 0.1 Hertz. Okay, that's the frequency. I adjust 100 millihertz. It is the same. The amplitude is 6 volt peak to peak, and it is a square wave. This is easy. Okay, so the function generator is going here. This is the ground here, the black line, and this is the input. The input here, I just use the middle one. So this is short circuit, this is R1 and this is R1. So this one acts like the inverting one. This is the same resistance, the same color here. So this is the inverting one. And the output is going to another operational amplifier. This is the second resistor, and this is, if we look here, this is the angle output. So this is the feedback from the angle. This is R1, and this is R2, which equal also to R1. So this is the summing output. This is going to the command input here. So this is the command input, which is the output of this volt. This is the ankle output. This is the feedback to my system, and this is the ground here. If you look at the motor, you are giving it a low frequency signal. So the motor start is a small overshoot and then stop, start overshoot and stop. Let's see this now. This is the angle output. We're taking it on the oscilloscope. So if we look here, we sent a square wave to the motor. If you look here, this is overshoot, then settling, overshoot, then settling, overshoot, then settling every time. The overshoot here is around 2 and just a bit volt, which is roughly 40% of the amplitude of the 6 volt amplitude. So that's the overshoot. So that's kind of what we are expecting. If you correctly set this circuit and everything is correct properly, you'll get the same diagram like this. Make sure that you open this to compute, and make sure that you press the power button here. So there is a power button here in this circuit, and make this compute. The default is reset, make it compute, and if you want to turn it off, make it reset. Okay, so this is the first part. It is an easy part. We have already seen the overshoot. The second part, we can look at on the PDF here. So the first part, we connected the ground, we tested the signal generator, we looked at the scope, and we used 6 volt 0.1 hertz, and we set the motor to inhibit, set the revolution to 2 rev. We have opened the system and set it to compute, and we have observed the overshoot of 40%. Recall the resistor code and confirm that the orange components have 10 kilohertz to 10 kilo ohm resistance. What is the color code? The color code of resistance, it means that every color is equivalent to a number, and I can read this number and know what is the value of the resistance. What is the color code? The color code is for every number 0, 1, 2 to 9, there is a color. So I'll call them quickly, and you need to make a search and know how these values can be read from the resistors. So for 0 it is black, brown, red, orange, yellow, green, blue, violet, gray, white. So white is 9 and the black is 0. Black, brown, red, orange, yellow, green, blue, violet, gray, white. I want you to search about the tolerance of this resistance and how can I read them as well. So it's part of your lab. Try to find it, it's easy. Okay, we finish this part. We go to the second part to find what is the peak frequency and the peak gains. So what we'll do, we'll switch instead of using a square wave, we'll switch to sinusoidal wave, and we begin using different frequencies. Every time we'll use different frequencies and try to find out which frequency have the highest peak to peak and the highest, what is the frequency at which we have the highest peak to peak voltage. So it's a sinusoidal signal, 6 volt. The output should be something between 1 hertz and 3 hertz. So, okay, I'm cheating here. Okay, so you'll search about this frequency, but we know it's something between 1 hertz and 3 hertz. Once we get this maximum frequency and the maximum amplitude, using the theoretical part, we can calculate the constants of the motor we are using. After this, please return everything as it is, close everything, turn everything off, and return the equipment where you get them. Okay, let's do this part now. So we start here. This is the 6 volt peak to peak. The frequency is 100 millihertz, but we want it sinusoidal. Okay, let's turn this off first, make it sinusoidal, and then return this on again. If you look at the oscilloscope, this is not sinusoidal, right? It's like a distorted signal. Why it is distorted? Because the frequency now is 0.1 hertz. 0.1 hertz is very small values. In this case, the linearity of the motor is very obvious. As we see, this is not good. Okay, let's try to increase the frequency slowly. That's 0.1, that's 0.2, 0.3 hertz. Still going on. Oh, the linearity now is no longer apparent at first. So the linearity appears at very low frequency. Okay, I'm increasing the values. Can you realize that the amplitude is increasing? It's increasing very slowly. You need to look carefully to realize this. Because actually I'm increasing in parts of hertz, like 0.1 hertz, 0.2 hertz, 0.3 hertz. But it's increasing, it's still increasing. Oh, it touches the cursor now. It's about 1.9 hertz and it touches the cursor. It's just above the cursor. Oh, it's going down again. So it's like from it's now 2.4 hertz. It's smaller than 2.4 hertz and bigger than 1.8 hertz. So it's actually between 1 and 3 hertz. Once you try to get exactly to the peak frequency as much as you can. Once you get the peak frequency, you measure the peak amplitude from here. Using these values, you can find the motor constants as you have derived in the theoretical part. Just if you finish this part, you have already the 7 questions done at home, and these 2 parts, you get these numbers and calculate the constants. You have your report ready to be done. So you go for the last the laboratory report, and you finish and submit it in the lab. Please read this part also at home, because so you have your idea what you are gonna write in the lab. That's lab 2. Thank you.